Okay, so 4.1 system of linear equations. So the basic idea here is being able to solve more than one equation at a time. So that's what we're going to investigate. So a system, not just any system, but a linear system is a set of two or more equations, linear equations. And most of the time, the way that they're going to be written is some variation of kind of like this. So you'll have ax plus by equals c, and then dx plus ey equals f, right? That's kind of what a linear system is. And our main goal with these is being able to solve them, right? So what does it mean to actually solve one of these? Well, that means the following. So a solution to a linear system is the set of all values which are going to be ordered pairs that make all of the equations true. That means if you plug in the number into all of the equations, they all give you like 5 equals 5, or, they're all true statements. And it has to work for all of them. It can't just work for one of them and not the other. So it has to make all of the equations true. And just to make that more obvious, at the same time. So the nice thing about linear equations fundamentally, unlike your quadratics and your cubics and your exponentials, is there's only 3 options for the solutions, right? And there's no more and there's no less, right? There's only 3 options ever. And it doesn't matter how many equations you have. You could have 15 equations, 15 variables, and there's only 3 cases for the solution, right? And so the first case is going to be, okay, if you think about it, you have 2 lines, right? And what can these 2 lines do to each other? Well, the first thing they could do is they could cross each other, right? So we have crossing lines, or as we like to say, intersecting lines, right? And so if you have 2 intersecting lines, we call that a unique solution, right? So this is a unique. Another way of also talking about this is the one solution case, right? There's only one solution. And the solution is just going to be some x comma y value, right? So that's your answer, wherever they cross each other. So if 2 lines can cross each other, then the opposite of that would be, okay, what if the lines never cross each other? Well, that would look like this. So you have one line like that, one line like that. We call those parallel lines. And so this is the case of no solution, right? That's really it. There's no solution. And so if 2 lines can cross each other, 2 lines can be parallel to each other. And we ask ourselves, okay, well, what's the third option? Well, what if the lines are right on top of each other, right? So that is the final case. The 2 lines are right on top, like that. I think a proper term for it is coincidental lines, but you don't really need to say that. And this is called the infinite solution case. Another word people might say is many. Okay. When it comes to no solution, you might hear this is like the 0 solution, although you got to be careful because that doesn't mean 0 is the solution. That means there is 0 solution. So that you kind of have to be careful if you're to say it that way, right? But those are the 3 cases. Like that's really what you're going to be looking for in terms of solving these, right? And if you're thinking about it like in the context of like, okay, which one is the most important? Like which one would they most likely test me on? If we're talking like a linear algebra class, the infinite solution case is way more popular because it's more interesting, right? No math class is really going to focus on the no solution case because it's boring, right? There's no solution unless you start getting into like what's it called? Least squares approximation and estimation, but in 211, you don't do that. So the unique solution is actually more interesting for a class like Math 211 because a lot of the times we're looking for a unique or optimal solution. So in the case of Math 211, the unique solution is actually probably the most popular one because in the context of like solving application, constraint, optimization problems, we want unique solutions, right? So I would say the unique solution is probably the most important. Okay. And so now we have to talk about the different techniques that we can use to solve these, right? And so let's just introduce those techniques. And so the two techniques that are most common are elimination and substitution method. These are old school techniques, but no matter what math class you're taking, they're always valuable. You end up using them kind of a lot, just solving multiple equations and multiple variables at a time. And eventually you do learn, after the first exam, you learn matrices. And matrices are actually elimination and substitution method, but without having to deal with all of the equations. You just deal with the numbers, and it does all the work for you. It's actually kind of very convenient that you can kind of get rid of this whole process eventually and just do it on a computer using matrices. Right? So elimination method, the basic idea is to manipulate equations to cancel out variable. It doesn't matter which variable you cancel out, but there is typically a better option, like there's a best choice, and then it gets worse and worse, right? So how do you do that? First, look for any letter with coefficient 1. And if you're wondering, like, what does that mean? It just means the letter is by itself, right? Like X or Y. There's no number in front of it. We'll take a negative, like negative's okay, but there's no number in front of it, right? If that's not true, so this is the progression you're taking as you're trying to pick your elimination. Okay, so if there's no X and Y by itself, the next thing I personally look for is a variable already opposite signs. So basically, that would be like a 2x and negative 4x. Like they're already opposite signs of each other, right? Like if that's the next best thing, right? And then after that, kind of depends. Actually, let me do 2x and negative x, like, well, actually, 3x. There we go. Because to me, that's kind of better, right? I don't have to deal with negative manipulation. After that, variables that are nice multiples. So, 5x and 10x, right? One's a multiple of the other. 5 can divide into 10, so I'd only have to manipulate one equation. In fact, I would probably swap 2 and 3, but that's okay. And then the last step is just like the smallest numbers. Now, the best part about this is at the end of the day, it doesn't matter what you pick. What matters is once you pick something, just do all of your algebra correctly, like do the computations correctly. And as long as you do that, you will get the same answer no matter what variable you pick, what numbers you multiply it by. You always get the same answer. Your goal is just to minimize basically how much work you have to do. And I would swap 2 and 3. I think doing step 3 would be better at 2, but that's kind of the idea. For substitution, the idea is to isolate a variable in one equation and sub it into the other equation. So then the question becomes like, okay, which variable do I pick? It's kind of the same idea, right? So the first choice would be any letter already isolated. So sometimes you will get equations where one of the equation is just like x equals 10, right? Like that's already isolated for you, okay? And if that's not true, then any letter with coefficient 1. Now, why would I want coefficient 1? Just because isolating the letter becomes easier. You don't have to divide by anything. So that way you don't create fractions. And then number 3 is letter with best number. So the best number is anything that will divide perfectly, but if not, then just pick whichever one creates the least amount of fractions or the one that creates the best fractions that you like to work with, right? So again, personal preference, but and then there are some like interesting manipulations that you could do, but in the context of like linear systems, it's not really going to be that important. In nonlinear analysis, you do sometimes have to do like fancy tricks to get the substitution, but this is focused on linear only, so you don't have to worry about that. But those are the two methods, essentially. Is elimination is probably more preferred in the long run by students because it tends to just be nicer to work with. But substitution is always valuable because sometimes the substitution might actually be easier and faster than elimination, especially when the numbers are not really nice. But again, it just depends on the problem. So, and substitution is always better when one of the equations only has one variable because eliminating with missing variables is just kind of annoying. So, but these are the two methods. We're going to practice doing each of them in the next few examples. And then we also want to practice just seeing the different types of solutions that you can run into when doing linear systems, right? All right. So our first example is going to be solving this linear system. And so the technique that we'll use for this one is we could do substitution. Like we'll do substitution first. And then on the next example, we can do something like elimination or something. Okay. So if we're going to do substitution, the first step is to pick a variable to isolate. Right? So pick variable to isolate. Now, it's not a bad idea to label your equations like 1 and 2, just so you know which equation you're talking about. And again, following my progression, I want to pick a letter that's by itself, like, so there is none that's purely by itself. So then, are there any variables with coefficient 1? And I look and I have two options. I have x and y, right? So it's at that point you can decide, okay, which one do I like more? Me personally, I think x is better because it doesn't have a minus sign in front of it, right? So I'm going to pick x. But y would be 100% fine. In fact, any of those numbers is honestly fine, but the other two would create fractions, and you don't want that. So I'm going to isolate x in equation number 2. Like that's the one I'm isolating. So that's what I'm going to do next. So now we isolate. So we isolate the variable. So you take your equation, and then you just move everything over that's not x. So minus 2y, minus 2y. And remember, when you're combining like terms, don't combine numbers with letters. So 5 can't combine with y or x. 5 is just a constant, right? So x can only combine with x. Y can only combine with y. Okay, so this is my new equation. It's not a bad idea to give this a label, so I'll call it equation number 3, or sometimes I call it star, right? Because it's a new equation. And so now that I've isolated the variable and I have a new equation, the whole substitution comes into play where we sub in this new equation 3 into, okay, so this is important and this is where sometimes the mistake happens. You always have to plug it into the equation you didn't use to isolate. So I used equation 2, which means I'm going to use equation 1, okay? So equation not used, okay? Because if you plug an equation into itself, you will always get 0 equals 0, okay? You don't want that in this case. So we're going to sub 3 into 2. And so the way we do that is we do 3x minus y equals 8. That's equation number 1. And then wherever there is an x, I am going to substitute it in with the 5 minus 2y. Now I am just going to grab this, just to have space, I'm going to move it up here. And so I'm going to replace the x with 5 minus 2y minus y equals 8, like that. And then we distribute the 5 into each one. So 15 minus 6y minus y equals 8. The y's combined to be 7y equals 8. And then from here, we just got to solve. So minus 15. So negative 7y equals negative 7. I divide the negative 7 over, and I get y is equal to positive 1, like that. And so now we have solved for our y value. The next thing I have to solve for is the x value. Okay. So let's do that. I'm just going to move it up so I can try to keep this all in the one slide right there. Okay. So step 4 is now take your equation. Okay. Actually, let me into 1 and solve for y, just so that it's more descriptive of what we're doing. So we sub 3 into 1 and then solve for y. And then for step 4, solve for last variable. In this case, x. So now, does it matter which equation that you use to solve for x? No. But there is a best equation, and I would use equation number 3, because x is equal to 5 minus 2y. So then x is equal to 5 minus 2 times 1. And so x is equal to 3. Right? So we get that number. And so once you have your two values, the final step that you could say is solution. And so x comma y is equal to 3 comma 1, right? And so most of the time you will write your final answer as an ordered pair. One mistake that I have seen many students make is that if they solve for y first, they'll write it down first in their ordered pair just because their brain thinks the first thing I solved is the first part of my answer. So always pay attention to what you label as x and y, just so that you have it in the correct order. And you can check your answer by just plugging in 3 and 1. So if you plug in 3, 3 plus 2 is 5, so that's good. And then if you plug in 3 and 1, 9 minus 1 is 8. So we can confirm our solution. So now let's do an example using elimination method. So that's what the next one's going to be for. What would you do if you had to use elimination method? Okay, so let's write that here. This is going to be elimination. So we're solving this system. And in the last example, we had one solution. So that was the unique solution case. So in this example, we're going to explore a different type of solution. But for step 1, you're going to pick a variable to eliminate. So pick a variable to eliminate. So you're not isolating a variable anymore. Now you're just saying, okay, which variable do I want to get rid of? It doesn't matter here. I would pick x just because x is smaller. Like that's my logic for it. So I'm going to pick x. That's all. Okay. Not in any equation, but just x as a whole. So then step 2 is to manipulate equations to make x the same number and opposite sign. So if I look at 2 and 6, the number that they both could share or be the same at is 6 because 2 times 3 is 6, but I have to make one of them negative. So I'm going to make the first equation negative. So the way that I would do that is I would write down my equation. So 2x minus 3y equals 4. And I put the whole thing in parentheses and I multiply it by whatever number I want to modify it by, like that. And so then now I just write down that new equation. So distribute the 3 negative, and And a common mistake people do make doing this is they forget to do the right side. So make sure that you do it on the right side. And we get something like that. Okay. So that's my new equation. So our updated system will be negative 6x plus 9y equals negative 12. And then 6x minus 9y is equal to 11, right? So that is what my system is going to be. And so from there, the next step will be the following. So step 3 is now add together. In practice, you're not going to like keep writing it over and over again, but just for the sake of this example, I'm just rewriting it so that you kind of follow the train of thought, but you can kind of do this like in the actual problem statement by just multiplying and then adding them like that. So we're going to add them together. And now if you did this correctly, one variable should always cancel out. So these canceled out. Now, sometimes, like in this example, both variables can cancel out. So if the variables all cancel out, you're left with a 0, okay? And then on the right side, negative 12 plus 11 is going to be equal to negative 1. And so then you read and you see 0 equals negative 1. We know that this is false. And so the answer is no solution. And you're done. There's no more analysis that needs to be done. The two equations are parallel to each other, which means they will never cross, which means there is no solution, right? And so that's what a no solution case looks like. So the third and final case that we're going to look at is the infinite solution. And so when doing infinite solution, it's the same thing as the no solution, but then there's a little bit extra at the very end. So from here, we'll do elimination. So we're going to do elimination method. So the first step for elimination method is going to be to pick a variable. But if you notice, we have fractions. So can you work with fractions normally and just kind of deal with them? Yes, and that's perfectly fine. But here's a little trick. If you can identify the largest denominator, right? If you multiply the equation by the largest denominator, it will usually cancel them all out, okay? Well, I should say it more properly. If you find the least common multiple or the greatest common denominator of all of the denominators and you multiply across, it will cancel them all out, right? So that's what we're going to do. So step 1 here is kind of a extra step, and that's just to get rid of fractions. And the reason I'm getting rid of the fractions is because then it'll help me choose what variable I want to eliminate. So if I look at the second equation and I notice that they all have a 3 denominator, I'm just going to multiply by 3. So why am I doing that? Because it gets rid of the fraction. So if I distribute, I get negative 3x minus 5y equals negative 1. Fraction is gone. Now my life is a lot better. Okay, so 3x plus 5y equals 1. Negative x minus 5/3 y equals negative. Oops, I'm copying down the original equation. Let's copy this down correctly. So negative 3x minus 5y equals negative 1. So now we have our updated system. So then step 2 is pick variable to eliminate. Now, when it comes to linear systems, and specifically when you have 2 equations, 2 variables, the infinite solution tends to be pretty obvious in that the equations are either the same equation, just opposite signs, or they're multiples of each other, like one is double or one is triple or so, or half, right? So you can usually tell when it's infinite when you see these enough times. So I'm going to pick x. Step 3 is just to add together. I don't need to manipulate because it's already, equal and opposite. So we're good to go. So 3x plus 5y equals positive 1. And then negative 3x minus 5y equals negative 1. And if I add those together, these cancel out, and I'm left with 0 equals 0. And so this right here is called the infinite solution, right? So this would be infinite solutions. And if the homework or the problem said, I just want to know how many solutions, you would be done. Like, this is the correct answer. You don't need to go any further. However, they're often going to ask you to parameterize it. So if you read the directions, they'll say, like, if there is infinite solution, parameterize the answer in terms of one variable. So that's what we're going to do next, which is step 4, which is parameterize the variable. There are 2 techniques for parameterization. The one that I'm going to show you is the one that you guys use in Mat 211. But in a class like linear algebra, we have a different style of parameterization. Both are completely valid. I personally prefer the other way, but the other way will not be the same as your homework problems and how you enter in the actual answer. So what they'll usually tell you is they'll give you they'll tell you which letter is the parameter. So in the homework case, usually it's x. So they're going to say, let x be the parameter okay, then solve. So let x be the parameter. So you just solve for y in either equation. That's all you have to do. You're going to solve for y. Okay. So it doesn't matter which equation you take. So I'll take the first one. 3x plus 5y is equal to 1. And I just want you to solve for y. So we're going to get y by itself. So I'm going to move the 3x over. And so I get 5y equals 1 minus 3x. I'm going to divide both sides by 5. And so I get y equals 1 minus 3x over 5. Okay. And so now you have y by itself. And so the final step for this is now you're just going to rewrite your solution or your xy coordinate in terms of just one letter. Hence, that's what parameterization is all about. It's basically taking 2 letters that are, independent of each other. They don't interact with each other directly, and then we're tying them together to a single letter. Me personally, I prefer to use a different letter. I don't like reusing the same letter, but in this case, they kind of do. So step 5 is ordered pair. So remember, it doesn't matter what kind of linear system you're doing. The answer is always x comma y. Like, that's your answer. So this is equal to the solution. Now, we found that there are infinite solutions, meaning if you pick 2 numbers that are on the line, it'll work for both equations all the time, right? So any point along the line will always work. So there's a lot of them. So we were told x is equal to the parameter. So x comma y. So they said let x be the parameter. So you're just going to write x again. And then y is going to be written in terms of x. So we were told, or we found, sorry, that y is equal to 1 minus 3x. So now this becomes 1 minus 3x over 5. Okay. So that is the parameterization of the solution, and that is how you will write your solution on the homework. Now, if you're wondering, what does that actually mean? So the idea is if your solution, right, just to give you an idea, let's say that this is your curve. So let's see, if you subtract over, it's going to be a negative number. So this is kind of a rough sketch of what the graph would look like. If I asked you, hey, I want you to give me two coordinates on the line, just pick two random numbers and tell me if that's a solution. Well, if you pick two random numbers like 0, 0, that wouldn't work because it's not on the line, right? So 0, 0 would not work. And then you say, like, what about 10, 10? Nope, that doesn't work either. So you're just guessing two numbers randomly, right? What parameterization does is, like, you basically say, okay, give me one number. Okay, I'm going to give you the number 1. And then I'm going to be like, okay, I plug in 1 for x, and then I plug in 1 into that y coordinate that also has an x. So that would be, what would it be? Negative 2/5. And now I have an answer. So by me only giving you one number, I was able to create a coordinate that's on the line automatically without having to think about it. So, like, there's a guarantee that your point will be on the line, and it is a solution, versus me randomly guessing x and y coordinates and hoping it's on the line. So that's what parameterization is all about. It's just basically making it much more specific in where the coordinate is going to be on the line. So now let's apply this to a word problem. And so this word problem comes from your practice exam, which is located on the Mat 211 website. Everyone has access to that. So you manage an ice cream factory that makes 2 flavors, creamy vanilla and continental mocha. Into each quart of creamy vanilla goes 2 eggs and 3 cups of cream. And into each quart of continental mocha go 1 egg and 3 cups of cream. You have in stock 550 eggs and 1050 cups of cream. How many quarts of each flavor should you make in order to use up all the eggs and cream? So when it comes to word problems, such as this, the most challenging part is making sure you have the right variables. So the first time you read this, you might think what the variable is something that it's not supposed to be. So my first instinct in reading this is I think the variables are going to be the eggs and the cups of cream. But then if you read the last sentence, which is what they're asking you, right? So what they're asking you to find is really the variables. They say, how many quarts of each flavor should you make? So the eggs and cream are not going to be your variables, okay? The variables are going to be how many quarts of each flavor are you going to make? So that's the key, is reading it enough times so that you understand what they're asking. And usually the last sentence will tell you exactly what they're asking for, right? So step number 1, no matter what the word problem is to reread it. You need to slow down a little bit and read what they're asking. So once you've done that, then step 2 is, okay, we're going to label variables. Now you can use X and Y, and I will use X and Y unless I feel like the letters are more convenient or they require me to use different variables, okay? So X will be the quarts of vanilla, and then Y will be the quarts of mocha. Now, if you're wondering, what if I got it backwards for some reason? That's fine. You'll get the correct answer. You just got to be careful that, like, on the homework, if they specifically tell you what letter is what, and you do it backwards and you put the answers in like that, your answer is technically not wrong. It's just, it's going to be wrong to what it's supposed to be labeled as, okay? So always pay attention to see if they make you pick a letter and they specifically assign a flavor to a letter. If not, then the general rule of thumb is the first thing that's talked about is the first variable, and the second thing that's talked about is the second variable. That's always a good rule of thumb. So then step 3 is, okay, we got our variables down. Now we got to set up our equations. Sometimes setting up the equations is actually the most difficult part, especially when they give you like those weird problems where, like, you make twice as many, but half the number of quarts of vanilla. Like, they start using words like that. And then that's where it gets challenging, because now you have to kind of use a little bit of like English logic and like, okay, half, more than, difference. Like, those problems can be more challenging. So this is more of a straightforward problem. So basically, we're going to have one equation for the eggs and one equation for the cream. So your variables are how many quarts you're making of each, but what decides what you make them are how many eggs you're going to use and how many cups of cream you're going to use, right? So if I'm making vanilla, I'm going to use 2 eggs, right? So 2 eggs for every quart of vanilla plus 1 egg for every quart of mocha. And I have a total of 550 eggs, right? That's how I got my equation. And then I apply the same idea to cream. 3 cups of cream for vanilla, and then 3 cups of cream for mocha. And I use 1,050 cups. Once you have done the equations, that's probably the hardest part of this whole problem, is to set up. Now you get to pick whichever method you want to use to solve, unless they tell you in the directions like, hey, I need you to use this method. So for us, you can just solve whichever one you want. So solve for x and y. So I'm going to use elimination method. Actually, let's do substitution, because substitution, elimination, I take it back. It's just less writing. So 550. 3x plus 3y equals 1050. So the way I showed you elimination method before is kind of the more formal, like I'm showing all of the work type situation. In practice, the way that I would personally do it is I would do something like, okay, I am going to do something like this. I want to make the y's cancel out, so I pick y, and I'm going to multiply this by -3, and I'm going to multiply this by -3, right? Because I'm canceling out the y term right here, and the y term right here. And so from there, my equation is going to become -6. Actually, let's do it like this. -6x minus 3y equals -1650. That sounds right. And there. And then 3x plus 3y equals 1050. And then I'm going to add them together. These are going to cancel out. I'm left with -3x, and I'm left with -600. A little tip for you when you're doing this, this is elimination method. So a little tip for you in doing this, if you're ever solving a problem like a word problem, if both of your numbers are negative, that's usually a good thing, because when you divide out the negatives, your answer is going to become positive. So if you ever get a negative number for most of the word problems, chances are you've made a mistake. The only exception is probably money problems, because you can have negative dollars. But if you're talking about like physical items, there's no such thing as like negative quarts or negative eggs. So that's one thing you can always look out for, is like, if I get a negative number and it doesn't make sense, let me go back and make sure I didn't forget a negative sign, or I added correctly, something like that. So then if you divide by -3, x is going to be equal to 200. And so the x is going to be vanilla, right? And so now all I have to do is solve for y. So thus, using any equation, I solve for y. So 2x plus y equals 550. And then 2 times 200 plus y equals 550. So then 400 plus y equals 550. So then y is equal to 150, because I subtracted the 400 over like that. And then this is going to be mocha, like that. So I need I'm going to make 150 quarts of mocha and 200 quarts of vanilla, right? So that ends up being my final answer.